Good morning, children. I just give some information regarding relations and functions. Relations and functions, it is a continuous chapters. We have it is in class 12th also. So the basic things of the relation which you study here, you have to make it is very concrete, so that you will not face any problem in class 12. Already we have learned about the Cartesian product. I just recapitulate it there. So A is a set with elements and B is another non-empty set. Then the Cartesian product of these two sets is defined as set of all ordered pair AB such that A belongs to the first set and B belongs to second set. This is the definition of the cross product or the Cartesian product of two sets. For example, if I take A is equal to 1, 2, 3 and B is equal to some 4, 5, then the Cartesian product is A into B is equal to 1, 4, that is 1, 4, 1, 5, then 2, 4, 2, 5, then 3, 4, 3, 5. And you can see that if there are 3 elements here, then and 2 elements here, the total number of elements in the Cartesian product will be 3 into 2, 6. That is, number of elements in A is M and number of elements in B is N. The number of elements in the Cartesian product A into B is M. And these things which we have learned in the last class, and some other terms which we would like to learn here is the domain, and one is domain, other one is codomain, and then a range, then image. These 4 terms you must know in connection with this definition of the relations. Now, let me take a set A, 1, 2, 3, 4, and another set B, 1, 2, 6. Now the Cartesian product A into B is 1, 1, 1, 2, then 2, 1, 2, 2, 3, 1, 3, 2, 4, 1, 4. This is the product. I take a subset of this one, this product set, and call it as R, and denote it as 1, 1. The subset is like this, 4. It is a subset of this one. You know that if a set is having n elements, then the number of subsets which we can form is 2 raised to n. That we write. Now, consider this subset. R is a subset. Here R is a subset of. Just make a observation for the elements of this one. Now the one element is 1, 1. What type of relations or connection is between these two elements? These two. What type of connection is there? If I say that this is the square of this one, this is the square of this one, that means here the element, first element and second elements are connected or related in a such a way that the first element is the square of the second element. Here also the same thing. So here the relation is square of. And this 1, 1, I can write in a mathematical way another way. 1 is related to 1. The other one, 4, 2, that one can be written as a 4 related to 2. So when you write like that, this R stands, the definition for R is square of. 1 is the square of 1. 4 is the square of 2. So here the specific relations, the specific connection between the elements of the first set and the elements of the second set is, what way it is connected? It is connected as the square element. And in the normal life also, in the family, when you take so and so is son of, so and so is daughter of, so and so is father of, mother of. These are the relations in our normal day-to-day life. We can see that. And if I take a student of class 11, they are 11 is a student of JNV Muflon. So that means that relation specific and a particular element when you take, what way it is connected to this. And here what way we are going to define is, a relation is always a subset of the product set. Product set, why we are taking, when the product set is there, then we have two sets. So elements of the first one is connected with the elements of the second one. Now I have marked like this. Suppose here 1, 2, 3, 4. This is the set A and this is the set B and 2. What is the set B? 1 and 2. And now see here. What way we are connected? 1 is connected to and 2 is 4. So 1 is connected and 4 is connected. So the relation here, this connection between two is R, is the relation here is square of. Okay. So in general we define the relation is a subset of a product set. Now I told the relation is a subset of the product set. Now you can see that 1, 2, 3, 4, 5, 6, 7, 8 elements are there. When 8 elements are there, how many subsets is possible? 2 raised to 8 subsets are possible in that case. So that means 2 raised to 8's relation we can form. In a relation is a subset of the product set. And in the product set, if 8 elements are there, 2 raised to 8 subsets can be formed. So that means 2 raised to 8 relation can be defined by using this one. So if a set is having, a set A is having m elements and a set B is having n elements, then the product set will be having how many elements? M into n, mn elements. When the product set is having mn elements, then the number of subsets is possible is 2 raised to mn. And when the 2 raised to mn subsets are possible, we can have a relation. How many number of relation? 2 raised to mn relation can be formed by using that one. That is the point to be noted. Now, so we are going to define the domain. Now the elements of the first set and second set is connected. You can see that this element and this element only having connections. We call the element, the set 1 and 4. This is the domain. Domain of that relation. So what way we have to take the point? Domain of a relation is the set of points of the first set which are connected. So here the 2 and 3 does not have any connection. So we cannot call that the complete A is the domain. Which are the elements of this set? You see, when we have a relation is the set of all ordered pair AB such that what is A belongs to A and B belongs to B, and the A and B are related by some way. Now, the domain of a relation, the domain of the relation is the set of points of A which are connected with the elements of B. So we call that is a domain. Now suppose I just make another example. A, B. This is A, B, C, D. Then 1, 2, 3, 4. We can call that what is the domain? A is the domain. This full set is the domain. And this set is called the codomain. Remember, domain of a relation. We have a relation from a set A to B. The domain of the relation is the subset of A. Actually, it is subset of A. Sometimes it is A itself. If all elements of A are connected with the elements of B, the complete A is called the domain of the relation. Here all the elements of A is connected with the elements of B. So complete A is called the domain. Now, codomain, whether all elements are connected to this side or not, complete set B, the second set, the complete second set is called the codomain. Complete, even 5 is not connected with the elements of any A, but the complete set is called the codomain. Now next image. See, the image of A is 1 here, and if I call that image of A is 1 under R, image of B is 4 under this R, image of C is 3 under this R, image of D is 2 under this R. So image of an element means to which element it is connected, that is called the image. Now the next is range, the range of a function. Now you can see that here except 5, all elements are having a connection, pre-connections you can say, except 5. So the range of this R is the set 1, 2, 3, 4. 5 will not come. So we can see the range is a subset of the codomain. Codomain is also second set. This range is also element from the second set. The difference between codomain and range is, in the range case only those elements of the second set is to be taken which is connected to the elements of the first set. So these are the some terms: domain, codomain, range and image. And I gave some questions like this. Say, the relation is given like this: 1, 2, 3, 4, 4, 5. Like this. This something is given like this. So if somebody asks a question to you, what is the domain of it? So domain is the first element. So domain is 1, 3, 4. Range is the second element. So 2, 4, 5 is the range. And codomain. The codomain should have all the second element 2, 4, 5, and we don't know what is the other element. Other element, sometimes there may be some extra element that to identify we should get some additional conditions. Okay. So this is the what way we will be finding out the domain, codomain, range and image, etc. Now I just explain about the function is the next one is function. Okay. The function is the next stage of the relation. First we have the Cartesian product of sets, and then we have the relations. Then next stage is going to the function. The definition of the function is a function is a relation in which each element of the first set is connected with one and only one element of the second set. Each element of the first set. Function is a relation in which each element of the first set is connected with one and only one element of second set. That is the definition of a function. Now let us see how the distinctions. They may be asking that some connection is given, whether it is a relation or a function, it will be asking too. Now let me draw some diagrams. Arrow diagram, we call it as arrow diagram. We know that the relation is the connection between two sets. Now here, this is one E. They are connected with some type of relation. Say, I take 1, 2, 3, 4, 5. 1, say A, B, C, D, something. Now, I made a connection like this. Now, observe this one. This is a relation. Elements of the first set is connected with elements of the second set. Now, whether it is a function or not, how to identify it? See, here the definition is each and every element of the first set should be connected with one and only one element of the second set. That is what it says. So now you see, this 5 does not have any connection. So it is not a relation. So not a function. It is a relation, but it is not a function because of 5 does not have any connection. Now see here, another one. 1, 2, 3, 4, 5. A, B, C, D, E. Now see this. Here it is A and they are connected with some relation. Whether this relation is a function or not. See, the element 1 is connected with A and 1 is connected with B. Both. The one element is connected with, it should be definition one and only one element of the second set. But here 1 is connected with 2 elements. Therefore, it is not a function. Now I take another. Element 1, all elements are having connection. 1 is connected with A, 2 is also connected with A. Doesn't matter. The definition does not valid. The definition says each and every element of the first set is connected with one and only one element of the second set. So each one is connected with one only element. 1, 2. So this is a function. Each and every element of the first set is connected with one and only one element of the second set. Here also each and every element of the first set is connected with one and only one element of the second set. So this is also a function. Normally the function will be denoted by f or g etc. from the set A to B. So a function is always a relation with some additional condition. Each and every element of the first set is connected with one and only one element of the second set. That is that. Now here also that the domain, codomain, range, all this will be there. What is the domain of this one? The domain is 1. Of course it is not a function. It is also not a function, so it is relation only. Relations, domain and codomain we have already discussed, and this is now function. What is the domain? This full set. The first set, full first set will be the domain. And what is the codomain? The full second set is the codomain. Full first, in the case of function, the full first set is the domain. Full second set is codomain. What is the range? It is a subset of the codomain, which are connected. So the A, C and D will come in the range. So that is the connection of this range. Now I can use, if f is the that we are using for the connection or function, then we can say the f of 1 is A, f of 2 is A, f of 3 is, sorry, f of 3 is C, etc. It goes. So this is image of 1. A is the image of 2. C is the image of 3. I'll share some of the question to you. Thank you.